Could you expand a little bit on the attenuation aspect? It seems like a very, very important topic in the measurement.
Yeah, okay. So, fundamentally, attenuation affects how far you can transmit before you need to re-amplify or regenerate the signal. And test engineers or the network engineers need to know what attenuation they're dealing with. And for the system engineer, knowing what that is at a number of different wavelengths is also important, especially for submarine cables where it becomes very critical. Now, so as I stated, attenuation is measured in a fiber plant at multiple wavelengths. Modern technology is going more from doing a full spectral measurement to doing several measurements with an OTDR, and then sort of modeling the shape of that attenuation with mathematics. So it's going from what we call a spectral bench to a multi-wavelength OTDR. PE.fiberoptics already produces the multi-wavelength bench, but we're also developing an OTDR that can do the same measurement. Now, when the fiber is delivered to the cable factory, they're going to put some ink on the fiber. That ink will introduce some macrobends, some stresses, which will increase the attenuation. So they need to measure it after that process. But they don't want to measure the full spectrum, they'll just measure one or two wavelengths. Then the fiber will be put into a tube with jelly, and it will experience further bends and stresses. So they'll test the fiber again. And yet again, they're going to measure this with an OTDR, not a full spectral bench. And then the tube is going to be stranded. Again, the fiber experiences more bends. So again, they will test after the stranding process. And once they've put the cable or the tube into the sheath, this will be the final condition for the cable in the factory. So they'll do what they call a final acceptance test for the cable, and they'll most probably measure this from both ends. I'll explain a little bit about what that means in a minute. So this sort of double up on the testing they do. So productivity of an OTDR becomes the most critical factor then in the cable factory. Once the cable is delivered to site, the cable is going to be strung from poles or it's going to be buried in ducts. They're going to be experiencing different stresses, different environments, and the attenuation the effects on the attenuation will be different for each application. So again, in the field, they're going to be measuring with an OTDR. They're not going to be able to do this with a full spectral bench because they don't have access to both ends. Now, when they're measuring these fibers at all the different parts of the process, somebody is taking note of all these changes, and they're using that to feed back into the process to improve the process. If they find they're getting more attenuation from the coloring line, they need to find out why that is. If they're getting more attenuation from the tubing line, they need to find out why that is, and then improve the process to reduce that. Now, I mentioned about bidirectional or measuring from both ends. It is understood that measuring with an OTDR only gives you the loss in one direction, and that in fact the loss in one direction is different to the loss in the other direction. So the true loss of the fiber is actually the average of the two. So they're going to measure it from both ends and take the average. That then gives you the value that's achieved by the full spectral bench. So you don't need to do from both ends on the full spectral bench. Now, some people assume that this difference in loss is small and they can justify not measuring from both ends. And this is really down to a customer acceptance. Do they accept bidirectional or from one direction? It's negotiated between manufacturer and supplier.